to all of you. Okay, so today we just cover for the tutorials 2. Okay, all right. So and tomorrow we try to cover on the tutorial 3. Okay, class. So can we start now? Boleh dengar tak suara saya?
Boleh.
Okay, so that I mentioned to you. So today no lecture. All right. So we try to cover on the tutorial 2. Okay, so because of our lecture will be finished on the chapter 3. So tomorrow we discuss about the tutorial 3. So I think the midterms, okay, the midterm tests, I think will be covered for chapter 1, chapter 2, until chapter 3 lah. Okay, until AC meters, okay. Right, so that's why I try to cover for tutorial 2 and tutorial 3 lah, before midterms, okay. Alright, so today we try to cover for tutorial 2. Okay, so yeah, suppose you have to print this one lah. So we have on the tutorial 2, we have 8 questions. You can try, alright. So let's go one by one. Okay, so tutorial 2. Okay, so on the tutorial 2, okay, so you can read on the tutorial 2, the emitter has in the figure 1 has the PMMC. PMMC is the permanent magnet moving coil instrument with a coil resistance of RM 99 ohms and full scale deflection current of 0.1 milliampere. Okay, the shunt resistor RS equal to 1 ohms. Okay, determine the total current passing through the emitter at full scale deflection. Okay, for number A, and then B is a 0.5. Okay, and C 0.25 full scale deflection. All right, so first, okay, so this is for solution, for the solution for tutorial 1. Okay. Right, so actually this is our script. Okay, so this is RM. Okay, this is a shine. Okay, so this is a current total. Right, so this is current shine and this is IM. Okay, all right. So this one we given RM equals to 99 ohms. Okay, so the current full scale deflection is a 0.1 ampere. Actually, full scale deflection is equals to this one, to IM. Okay, that means the current full scale deflection equals to IM. Actually, is in here. All right, in here. Okay, in this point, current in here, and then resistance shine equals to 1 ohm. All right, so that mentioned to you. So voltage in parallel will be same. That means voltage here. Okay, voltage shine and voltage VM equals, okay, cost of the parallels. So I1 actually is I shine plus IM lah. Okay, this is a standard formula for this circuit. All right, okay, so the question number 1, okay, A is the full scale deflection lah. Full scale deflection. Okay, so all right, so this is the current that mentioned to you. So the current equals to full scale deflection. plus this one we call IM, okay, equals to VM. Okay, this one because of the voltage is the parallel is the same. Okay, equals to IM. Okay, voltage here. So to calculate the voltage VMs, okay, IM multiplied by RM. Okay, divide by Mr. here. Okay, so equals to 0.1 milliampere. Okay, multiplied by 9.9 ohms. Okay, divide by 1. So the answer is 9.9 milliampere. Okay, that is for current China. Okay, and then you have to get the current total. Okay, equals to 9.9 ampere plus 0.1 0.1 IM. Okay, so the total current will be 10 milliampere. Okay, so that is the answer for full scale reflection current. Okay, and then second for the B, you can see for the B it mentioned about 0.5 full scale deflection. That means 50% to this, okay, to this one to full current deflection okay. So that means IM equals to 0.5 full scale deflection full scale is 0.1 okay. So it's a 0.05 milliampere. Okay, so that is so for IM, and then using the same concept with this one, okay, calculate the current shine, right? Just different is the 0.5 full scale deflection on the current IM just different on the rest is the same the formula will be same. Okay, so just multiply 0.05 milliampere multiplied by RM is 99. Okay, divide by current shine is the 1. Okay, so equals to right, so 4.5, okay, 4.95 milliampere, and then you have to calculate the I, okay, I 0.05. Okay, so this is IM plus 4.5 milliampere. Alright, so the answer is 5 milliampere. Okay, so this is for 0.5 full scale deflection 0.5 full scale deflection Alright, so the C, okay, for the C is the 0.25. That means 25% from the full scale deflection okay, full scale deflection. That means 0.25 full from the or 25% from the 0.1 okay, 0.1 milliampere. Okay, so the current here will be 0.025 milliampere. Okay, and then using the same, okay, the same formula, calculate the current shine. Okay, IM is 0.025 milliampere. All right, multiplied by 99 divided by 1. Okay, so the answer is for current shine 2.475 milliampere. Okay, and then we have to calculate the I 0.025 plus 2.475 milliampere. Okay, this is milli. So the answer will be 2.5. Okay, 2.5 milliampere. Alright, okay, so that is the solution for tutorial 1 tutorial 2, question number 1. Okay, So the first is the 10, okay, is the 10 milliampere. Second is the 5 milliampere. Okay, actually reduce 50%. Okay, for example, okay, so for example, the full scale deflection current we got 10 milliampere, the total current here. So the total current here we got 10 milliampere. So if we reduce 50%, okay, this one that means 0.5 from the full scale deflection. All right, that means we reduce 50% here lah. That's why automatically from this one also you can use straightforward. Okay, straightforward divide by or multiply by 0.5 lah. Okay, so that's why the answer will be 5. Okay, and then for the C 0.25, that means 25% from the full scale deflation. Full scale deflation is 0.9. That means 25% reduced from 10% from 10 milliampere. That's why the answer will be 2.5 milliampere. Okay, so this is another technique you can solve lah. Okay, so this one you can do the one by one step, or you can from this one you can reduce to 50%. Okay, based on this one greater 50% from the full scale deflection. That means this output will be reduced also 50%. Okay, this one similar lah. If this one is 25% from the full scale deflection, all right, so and then this value will be reduced 25% lah. That's why, okay, if you multiply by 0.25, so you get the 2.5 milliampere. Right? Okay, so this is a question number 1 tutorial 2. Okay. Alright, class clear So this one that I mentioned to you so the basic is that this voltage, alright, so will be same with this one okay, this one you have to remember this one. Current, okay, the current total here we call IT. Alright, the current total will be I shine here plus with I am lah. That's another formula that you have to remember okay. Right, so that is for question number 1. Okay, next we try go for the question number 2. Okay, so you can read for the question number 2. The PMMC instrument have the full scale deflection of the 100 microampere and a coil resistance of 1 kilo ohms. Okay, calculate the required shunt resistance value to convert the instrument into the ammeter with, okay, first for A, full scale deflection is equal to 100 milliampere, and second B, full scale deflection equals to 1 ampere. Right, so first similar, you have to draw the circuit. Okay, question number 2. Okay, so given IM equals to 100, okay, 100 ampere, all right, and RM equals to 1 kilo ohm. Okay, so for the first number A is the full scale deflection IM. Full scale deflection equals to 100 milliampere. Right, so we have to calculate the IT, okay, or I total. So IM plus I shine okay, this is I shine sorry. Okay, so okay, a total, so we have to calculate a total. That means we have to, this one is IM lah. Okay, so we have to calculate the I shine here. Sorry, I shine. Okay, so IM I total divide minus with IM. Okay, so 100 milliampere minus with 100 micro. Okay, so the answer will be 99.9 milliampere lah. Alright, for current shine. And then calculate the resistance shine, it will be Vm divided by, okay, Vm is the 100 micro multiplied by 1 kilo, okay, divided by 99.9 milliampere. Okay, so the answer will be 1.001 ohms. Okay, that is for resistance shine, resistance shine. Or we can use another formula. Okay, so this is okay, this is another one method. So another formula that we can use using this one, N equals to I divided by, this is I total lah, and Im. Okay, all right, so 100 milliampere divided by 100 microampere. So the N ratio we got 1000. Okay, so to calculate the R shine is this is another formula that you can use, Rm n minus 1. Okay, so Rm equal to 1 kilo. Okay, so the N equals to 1000 minus 1. Okay, equals to 1.001 ohms. Okay, so this is for another formula. So we can use this one. Okay, from, okay, this is similar like the figure similar like before this. Okay, so we have the is R shine. So this is Rm. Okay, so this is IT. Okay, this is R shine. This is Rm. Okay, I am here, and this is current I shine. Okay, so the standard dimension to you, I am equal to voltage shine, and the current totals. Okay, current total is equal to current I am plus I shine. Okay, this is a okay, from this one derive. From this one you can derive using this one, or you can use straightforward using the another formula lah. Okay, another formula you can use this one to calculate the resistance shine equals to Rm divided by 1 minus 1. Okay, there is another formula lah. Alright, so for the B, okay, for the B, say full scale deflection. Okay, so the full scale deflection is 1 ampere. Okay, 1 ampere, given 1 ampere. Okay, so same using the, you can use straightforward using the this formula. Okay, or you can derive, okay, similar like before this. Okay, I shine, I am, Rm, okay, divided by current shine equals to 100 micro multiplied by 1 kilo. Okay, and 1 minus 100 micro. Okay, for I shine. So, and then the resistance shine is 0.10001 ohms. Okay, so this is for if full scale deflection is 1 ampere lah. Okay, for the resistor is 0.10001 ampere ohms. Okay, and then also we can use the another formula, Rm, okay, 1 minus 1. Okay, so Rm 1 kilo. Okay, so I am 1 over 100 micro. Okay, divide minus 1 equals to, Okay, will be same answer lah. 0.10001 ohm. Okay, so that is the solution for the tutorial 2, question number 2. All right, so the answer will be correct lah. So the answer for the A is the 1.001 ohms. Okay, and then for B is a 0.1010001 ohms. Okay, that is for question number 2. Okay. All right, so next we go for the we go for the question number 3. Okay, so the question number 3, actually we have mistake here. So you can check on your tutorial. So this one we have some mistake lah. You can see on the figure 2 here. So the PMMC instrument has the 3 resistor electron shine connected across it to make an emitter, as in the figure 2. Okay, so the resistance value are R1. Okay, this one is not R1. Okay, this is R3. Okay, that's why if you try this one, so the answer is not correct lah. So okay, so suppose like this. Okay, so the R1 equals to 4.5. Okay, so there is some mistake lah. Okay, so R2 is same. Okay, 0.45 ohms. Okay, and R3 will be R3 0.05. 0.05. Okay, that is the correct. So just change for R1 to R3, R3 to R1. Okay, before this in your tutorials, so R1 is equal to 0.05. Okay, you have to change to R3. All right, so R3 will be 0.05. So R1 will be 4.5. Okay, that is okay, so there is some mistake lah. Okay, some mistake on the tutorial 2, question number 3. Question number 3. So the R1 equals to 4.5. All right, so R2 will be same, 0.45 ohms. Okay, and R3 will be 0.05. Okay, so for example, from the graph we have the okay, so this one will be R3, R2, R1. Okay, so this is our RM. Okay, so this is RM. Okay, so now we have to calculate the range. Okay, the range for I1, we call I1 here. This one I1. This one we call I2. This one is the I3 lah. Okay. Alright, so given RM is the 1 kilo ohms, and then okay, the full scale deflection current full scale deflection equals to 50 microampere. Alright, and then we have to calculate this one. We have to calculate I1, I2, and I3. Okay, based on the given resistor lah here. So R1 will be 4.5. Okay, this one. So we know the current the resistance shine will be R1 plus R2 plus R3. Okay, so 4.1 plus 0.45 plus 0.05. So RS is equal to 5 ohms. Okay, so the current total here, the resistance total here will be 5 ohms. Okay. Okay, so this one you can use the formula lah. Okay, you can use the formula. Okay. Okay, to calculate the shine equals to Rm 1 minus n minus 1 lah. So okay, so our shine given this one we get 5 ohms. Okay, and then Rm this one, and then we have to calculate the Im lah. Okay, first we have to calculate the n first. Okay, so this one okay given. All right, so n equals to, using this formula lah, 1k divided by 5 plus 1 lah. Okay, so the ratio okay for this one is 101 101, and then n, as you know, I total I1 lah, I1 divided by Im. Okay, so we want to calculate the I1. Okay, so n multiplied by Im. Okay, 101 multiplied by 50 micro lah. So the answer will be 10.05 milliampere. Right? So this is for question question range for this one I1. Okay, I1 here Alright, so you can use this formula or you can derive lah. Okay, that means R total here. Okay, similar like before this, the same formula. You can use okay, or you can use this formula. R shine equals to Im Rm shine. Okay, you can use this formula also Okay, so the next for calculate the R2. Okay, so the R2. So from the part B, okay, this one you can see on the notes. Actually, already give the formula. So formula for R on the slide for the formula RB and plus RC. That means here R2, this one R2 and R3 lah. Okay, this one So on the slide, this one as the known as the RA, RB and RC lah. Okay, so equals to Im okay shine plus Rm okay divide by I2 okay here. Alright, okay, so this formula already given so you can refer on the slide. Okay, this formula will be given don't worry. So this okay, alright, so you can see this one. So for example, to calculate the I2 equals to Im okay Rm okay R2 plus R3 lah. Okay, alright, so Im is equal to 50 micro. Okay, so R shine is 5 plus Rm is 1 kilo ohms. Okay, divide by R2 0.45 plus R3 0.05. Okay, so the answer will be hundreds. Okay, 100.05. Okay, 100.505 milliampere. Okay, you can try this one calculate using your calculator. Okay, you can calculate this one 50 micro. Okay, multiply by 1k. Okay, plus 5. Okay, divide by 0.45 plus 0.05. Okay, so the answer will be 100 okay, 100.5. Okay, 100.5 100.5 milliampere. Okay, 100.5 milliampere. And then next you can try lah. Next for the calculate the I3. Okay, I3. Okay, this one also you can use the formula lah on the slide. We're given the formula this one. Okay, so I am R shine plus RM by R3. Okay, R3. So 50 micro. Okay, 1 kilo plus 5 divided by okay, R3 0.05. Okay, so this is for I3. Okay, using your calculator, you can try this one. Okay, 50 micro. Okay, micro multiplied by 1K plus 5. Okay, divided by 0.05. Okay, the answer will be 1.005 ampere. Okay, that is the correct answer. Okay. Okay, so on your tutorial, this one is we have some mistake. Okay, you have to check this one. You have to change on your tutorial 2, question number 3. So the R1, okay, the R1 will be 4.5. The R1 will be 4.5. On your tutorial is the 0.05, so you have to change 4.5. Okay, that means R1 change to R3, R3 change to R1. Okay, R2 will be maintained. R2 will be same 0.45. Okay, R3 will be 0.05. Okay, so this is some mistake lah on the tutorial. You have to check lah. So the R1 will be 4.5. It's not 0.05. Okay, so the R3 will be 0.05. Okay, you have to change on your tutorial lah. And also we have some correction on the answer lah. So the answer, the first will be for the range for I1 is equals to 10.05 milliampere. Okay, milliampere. For I2 will be 100.5 milliampere, and then for the I3 will be 1.005 ampere. Okay, that is correct answer lah for the tutorial 2, question number 3. Normally we have to find the R1, R2, and R3. So this range normally given. Okay, for example, like I1. Okay, normally for the normal practice. So this one will be given. For example, this is 10 milliampere. All right. So this is 1 ampere. Okay, this is 10 ampere. For example. All right. Normally this range will be given. Okay. You have to find the resistor, R1, R2, and R3. All right. So here, okay, they change. Okay, they're given the R1, R2, and R3, but you have to find the range. Okay, so normally the range, okay, you can see, normally our range actually is a fixed. For example, like 10 milliampere, 1 ampere, 10 ampere. It's not like this point, 1.005, okay, 10.05 ampere, no. So normally like this, okay, 10 ampere, 1 ampere, 10 ampere, and so on. Okay, is okay. The range will be fixed. Normally, fixed is the fixed value lah. That means for example, like 10 milliampere. Okay, not 10 point something lah. Okay, for example, like 1 ampere or 10 ampere. Okay, so that is for question number 3. All right, so next we go for the question number 4. Okay, question number 4. Okay, question number 4. Okay, the emitter is connected to the measure the current of 10 ohms load supply from the 10 volt source as in figure 3. Okay, so calculate the circuit current if the emitter resistance Rs is, first for A is the 0.1 ohms and for B is the 1 ohms. Okay, also in each case calculate the effects of the emitter on the current level lah. Right. Okay, so you can see on the tutorial 3. tutorial 2, question number 4. Okay. So this is for example, like this is our circuit. Okay, this is RL. Right. So this is I. Okay. So this is for volt, 10 volt. All right. So from this one, okay, from this actually we can calculate the current, the current here lah. Okay, this is formula formula V equals to IR. All right, to calculate the current, voltage divide by R. Okay. So for example, okay, this one voltage 10 and then the R. Okay, 10. Okay. So this one the current will be M1 lah. All right. So the second, okay, we put some R shine here. All right, and then you have the RL. Okay, this one RL, this one R shine. Okay, 10 volts. Okay, to calculate the current here. So that's why same formula. Okay, IM is the V over plus resistance lah. Okay, resistance in series, just we have to plus lah, RM plus R shine lah. Okay, this one So because of the series, we just add lah RL plus R shine. Okay, so equals to 0.1. Sorry, this is 10. Okay, 10. Okay, RL is the 10 ohms. Okay, for R shine is the 0.1. Okay, the first, if the R shine will be given 0.1 ohms. Okay, so the answer will be 0.99 ampere. All right, 0.99 ampere. And then we have to calculate the okay, the effect of the emitter on the current level lah. All right, so we got this one. We have to calculate the insertion error lah. Okay, this is formula for insertion error. We call insertion error. Okay, so 1 over IM I. Okay, multiply by 100 lah. In percentage in 100%. Okay, so 1 over 0.99. Okay, so already calculate here, and then our I, okay, I is already calculate here, so multiply by 100. Okay, so the answer will be 1% lah. Okay, 1%, almost 1% lah. Okay, the answer will be 0.99%. So equivalent to 1% lah. Okay, 1%. That is for A. That means RM equal to 0.1 ohms. Okay, and then you can also try for the if RM I shine equals to equals to 1 ohms lah. 1 ohms. Okay, will be same. Part B Part B equals to RM equals to 1 ohms lah. Okay, so will be same, similar like before this. Okay, V divided by RL plus RM. Okay, so V equal to 10. RL is the 10. Okay, RM is 1. Okay, so the answer will be 0.9. Okay, 0.909 lah. Okay, 0.9 ampere. Alright, and then calculate the insertion error. Okay, with the same formula. IM I multiplied by hundreds. Okay, because on the percentage. Okay, 1 over current IM will be calculated is 0.9009 divided by 1. multiplied by 100. So the answer will be 9.09. Okay, percent, okay, or equivalence to 9.1 lah. Okay, that's why you can check on the answer will be correct. So this is okay, the exception error. All right, for part B, part B, if the RM equals to 1 ohm. Okay, that is for question number 4. Okay, question number 4. Okay, so next we can try on the question number 5. Question number 5. All right, so you can read on the question number 5. The PMMC instrument with the full scale deflection of 100 microampere and the coil resistance of 1 kilo ohms in the figure 4 to be converted into the voltmeter. Right. So determine the required multiplier resistance. If the voltmeter is to measure 100 volt at the full scales. Okay. So also calculate the applied voltage when the instrument indicates 0.75, okay, 0.5 and 0.25, okay, 0.25. Okay, so this is for question number 5. Okay, question number 5. Okay, so you have to, okay, so this is our skirt. Okay, so these are showing. Okay, and then we have the RM here. Okay, so this is plus minus. Okay, so this IM for IM. Okay, so this is a full scale deflection. Okay, so we be given IM equals to 100 microampere. Okay, so RM equals to 1 kilo, right? 1 kilo ohms. Okay, and then the range, okay, the range equals to 100, full scale 100, full scale deflection. All right, so first we have to calculate the sensitivity lah. Okay, the formula to calculate the resistor I shine here. Okay, so this is formula lah. I shine S. Okay, S is the sensitivity multiplied by range. Okay, minus RM. Okay, this is the formula. Formula to calculate the voltage multiplier, or we call the resistor shine here. Sometimes we can also call as the multiplier resistance. Okay, this is we call the multiplier resistance. I shine here, or this is formula lah. Okay, this formula for calculate the multiplier resistor. S is a sensitivity. Okay, multiplied by range divide minus with RM lah. So to calculate the sensitivity, this is a formula 1 over full scale current, full scale deflection of current. Okay, so as we know, okay, 1 over 100 micro. Okay, 100 micro equivalent to 10 kilo ohm per volts. Okay, that is for sensitivity lah. Okay, for this part and then substitute the sensitivity to calculate the multiplier resistor. S equals to 10k multiplied by range is the hundreds. Okay, minus by RM is the 1 kilo. 1 kilo ohm, 1 kilo ohms. Okay, so the multiplier resistor is equals to 999 kilo ohms. Okay, that is for, alright, that is the answer for multiplier resistor. Okay, that is correct. Okay, so you can check. So the answer will be same lah. Okay, 999 kilo ohms. Okay, for the multiplier resistor. Alright, so if you can see also calculate the applied voltage when the instrument indicate 0. That's mean I mentioned to you. That means the second part is a 0.75. Okay, the part is a 0.5. Okay, that means okay 0.25. Okay, this means 0.75 from the full scale. Okay, the full scale deflection. Right, that's why lah. Okay, this one multiplied by 0.75 multiplied by 100. So that's why the answer will be 75 volts. Okay, this one will be 50 volts and this one will be 25 volts. Okay, all right. So that's why this is the answer lah. Answer for the voltage. Voltage if we apply 0.5 from the full scale deflection lah. Okay, so our full scale deflection is the hundreds. Okay, if we use the 0.5, that means 0.75, just multiply by 100. So this is the this is the voltage lah. Okay, for this. Okay, using for example, okay, you can also calculate the this. You can calculate the resistance shine if you use the 0.5. Okay, using this formula lah. Okay, using the same formula. Okay, so sensitivity will be same because we use the we use the so S is the 1 kilo. Okay, the range will be different lah, 25 and then okay. So this is the R shine using the 0.75. Okay, 0.5 from the full scale deflection lah. Okay, that is the answer lah. So you can use your calculator. Okay, to calculate the multiplier resistor. So 10k multiplied by 75, 1k. So the answer is 759 kilo ohms. Okay, and then also you can calculate the, for example, we use 0.5. Okay, 0.5, that means from the range is the 50 lah. So just change on the range is the 50. Okay, and also you can try for 0.25 lah. That means we use 25%. Okay, from the full scale deflection. Alright, so that is for question 5. Question 5. Okay, so next we go for the question 6. Okay, question 6 on the tutorial 2. Okay, so for question 6 will be PMMC instrument with a full scale deflection of 50 microampere and RM equals to 1700 ohm to be employed as the voltmeter with the range of 10 volt, 50 volt and 100 volts. Okay, calculate the required value for multiplier resistor for the circuit of the figure 5A and 5B lah. Okay. Okay, so this is similar like question number 3. Okay, so but this one the range will be given. The range will be given. Okay, 10 volt, 50 volt, and 100 volts. Okay, but you have to calculate the R1, R2, and R3. Okay, so this one you can see. So the connection. Okay, for the figure 5A and 5B is the different is the connection of the resistor lah. Okay, connection of the resistor. Okay, so for the figure A, 5A is the connected in the parallel. Okay, for the figure 5B connected in the series lah, in the series. Okay, for the resistor. Okay, so let's go for the part 1 lah. Part 1 is the if this is our circuit. Okay, this one R1, R2, R3, and okay, this is okay, so this is RM and current full scale deflection. Okay, so this. Okay, so we can okay, so this one the range will be given 10 volts. Okay, this one 50 volt. and then last range is the 100 volt. Okay, so you can connect to this one, okay, for the R1 or R2 or R3 lah. Alright, so for example, we start at the R1 lah. Okay, R1 at 10, that means at this one at 10 volts range. Okay, so the R1 equals to S multiplied by range, okay, minus Rm. Okay, so this is formula lah, calculate the R1. Okay, so this one will be, okay, if, okay, you can see this one, if we connect to this one, so this one will be ignore, okay, will be ignore. This one will be ignore. Right, that's why we can straightforward using the before this the formula. Alright, so this one we if resistor connect in the parallel, so that means this one will be ignored, right? Okay, it's not in series. That's why R2 and R3 will be ignored. Okay. That's why okay the range is 20k. Okay, multiplied by 10 minus Rm 1.7k. Okay, so the answer is 8.3 kilo ohm. Okay, that is for R11. Okay, to calculate the S that I mentioned to you, S 1 over full scale reflection, full scale reflection for S. Okay, so full scale reflection 50 micro. Okay, so that's why the sensitivity is 20 kilo watt per ohm per volt. That's why we can get this one, R11. Alright, clear? For example, if we connect to this one, so the R2 and R3 will be ignored. Okay, that's why the difference between the resistor connect in the series and the connect in the parallel. Okay, this one connect in the parallel. That's why R2 and R3 will be ignored. Okay, but if we connect to the at the 50 at the 50 range, okay, this one connect to this one. Okay, second part. Okay, same. You can use the same formula. So R2 equals to R range divided by Rm. Okay, so sensitivity is same. Okay, multiplied by 50. Okay, and then 1.7 kilo. All right, so the answer will be 999.8.3 kilo ohms. Okay, so that is for R2. Okay, R2. That means R1 and R3 will be ignored. Okay, will be ignored. Similar like R3. Okay, R3 at the, that means at the 100 volts. Okay, at 100 volt, R3 using the same formula because of the R1 and R2 will be ignored. Okay, S multiplied by range. Okay, Rm. Okay, so 20k multiplied by hundreds. Okay, minus 1.7k. Okay, so the answer will be 1.9983 mega ohm. Mega ohms. Okay, that is the answer for R1, R2, and R3. If we connect in the parallel. Okay, so if we connect in the parallel, you can see this one. For example, at the 10 range. Okay, so if you connect to this one, so this is automatically current will be not flow because of the this is open light, open circuit. This is open so the current will be flow like this. Okay, will flow like this. So that means R2 and R3 will be ignored. Okay, similar like this one. Similar if we connect to the 100 range. Okay, for this one. So the current will be flow to this one, Okay, so that means R1 and R2 will be ignored. Okay, because of the open circuit. So this one R1 and R2 will be ignored. Okay, so that is the difference between the resistor connect in the series and the parallel. Okay, so if you can see on the figure 5B, the resistor connect in the series lah. Okay, that's we go for the 5B. That is the resistor connect in the series. Okay, so this is our circuit. Okay, R1, R2, and R3. Okay, so this is RM. Okay, you can RM full scale reflection. Okay, so this is our point here. Okay, so this is point 1, point 2, point 3. Okay, so this range is 10 volts. Okay, based on the figure 5, figure 5B, 50 volt, and this one is the 100 volt. Okay, so this is R3, okay, R2, and R1. Okay. Okay. For example, okay, if we connect to this one, if we connect to this one, alright, so to add 10 volt, okay, if we connect to this one, so the current will be flow like this, okay, so this one will be ignored, R2 and R3 will be ignored, okay. So for example, okay, this, if we connect to this one, to 50, that means our R will be R1 plus R2. Okay, this one R1 plus R2. Okay, compare with figure 5B, 5A. So if we connect to this one, so normally the R1 and R2 will be ignored because of the parallel. But this one, so that's why this R1 will be this will be series lah. Okay, R1 and R2 will be in series. That's why for the, if we connect to the 50, okay, range, this means our resistor here, total here will be R1 plus R2 lah. Okay. Right, so for example, if we connect to this one, 100, okay, to 100 range, that means our R total will be R3 plus R2 plus R1. Okay. That is the difference between connect in series and parallel. Alright, so you can see this one. For if we connect to the 100 range, okay, that means our RT equals to R3 plus R2 plus R1. Okay, if we connect to 100 range lah, 100 range. Okay, for 50 range. Okay, so the RT equals to R2 plus R1. Okay, if 10 volts range, that means our RT equals to R1. Okay, that is the comparison between the parallel and series lah. If the parallel, so just which one the range lah. For example, for 100 range, that means we connect to the R3. Okay, for the 50 range, we connect to the R2. Okay, for example, for the parallel lah. Okay, for the series, so for 100 range, we have to add this resistor because this resistor connect in series lah. Okay, because the current will be flow like this. The current will be flow like this. You have to remember this one. The current will be flow like this. That's why, right? So the resistor in series will be, you have to add lah. Okay, and then if you connect to the 50 volt here, okay, so 50 volt, so the connect here, so the current will be flow from this one. Okay, R1 and R2. Okay, R1 and R2. That's why R1 plus R2 here. Okay, all right, go for this one. Okay, this is same lah. You can use the formula to calculate the R1, R2, and R3. If we connect to the the 10 volts. Okay, the 10 volt here, the 10 volt here. So you can calculate this R1. Okay, calculate this R1 using the formula before this. Okay, right. So there is different between the figure 5B and 5A. All right. So next we go for the question 7. Okay. Okay, you can see on the figure tutorial 2, question 7. Okay, the voltmeter on the 5 volt range is connected to measure the voltage across R2. Okay, 50 kilo ohms in the circuit shown in the figure 6, given by R1 equal to 70 kilo ohms. Okay, calculate the VR2. Okay, calculate VR2. Okay, the first for A without the meter connected. Okay, and then for the B with the voltmeter having a sensitivity of 20 kilo ohms per volts. Okay, and C with the voltmeter having the sensitivity of 200 kilo ohm per volts. Okay, first without the meter, second sensitivity is 20k, and C is the sensitivity is the 200k. Okay, for example, this is our circuit. This is R1, R2, R1, and R2. Okay, so this is okay, so R1. Okay, given R1 is the 70 kilo. Okay, 70 kilo ohms, and R2 will be 50 kilo ohms. Okay, so the voltage will be 12 volts. Okay, so calculate the voltage V2 lah. Okay, calculate the voltage here, part here. Okay, so this one is the straightforward lah. Okay, straightforward. You can use the, okay, this one we can use the voltage divider rules. Okay, or we can calculate this one. Calculate. Okay, this is calculate the current here. So calculate the current here and then multiply with R2. We can get the voltage here lah. Okay, normally we can use the we call the voltage divider rules lah. Okay, to R2 here. To calculate the voltage here, so we can use the we call the voltage divider rule. So this is formula for voltage divider rule: R2, R1 plus R2 multiplied by supply lah, our supply. Okay, volt here. Okay, so equals to R2 is the 50 kilo. Okay, multiplied by 12. This is our supply. Okay, R1 is 70k plus 50k. So the answer will be 5 volts. Okay, this one straightforward. We call this one voltage divider rules. Okay, voltage divider rules. Or you can use the straightforward. You can use the step by step lah. For example, okay, as you know, this one we can convert into the like this. Okay, this one RT lah. RT equal to R1 plus R2. Okay, so to calculate the current here. Okay, so this is 12 volts. So to calculate the current, so as we know, okay, V equal to IR. Okay, to calculate current. Okay, 12 divided by 70k plus 50k. Okay, right. So and then we get this current, this current, and then we have to multiply. So that's mean current. That's why you have to remember, current in series will be same. That's why current here and current here is same lah. So you can put as the current I1. This is I2. Okay, so the current I equals to I1 equals to I2 lah. That's why if you want to calculate the voltage here, okay, just formula this one lah. Okay, voltage VR2, current okay, so 70 kilo plus GK. Okay, so to get the voltage here lah, So you can use this one, or you can straightforward lah, calculate the current and then multiply with resistor. Okay, multiply with resistor, you can get the this one multiplied by 50 kilo lah, because of this one 50k. So the answer will be 5 volts. Okay, this is first without meter connected so without meter connected. So, okay, second part is the sensitivity of 20 kilo the S equals to 20 kilo ohm per volts. Okay, the sensitivity lah. Okay, formula, okay, Rm equals to S multiplied by range. Okay, so okay, so this one to 5 volt okay, so 20 multiplied by 5, okay, 5 because of you use the 5 volt range. Okay, so will be 100 Rm will be 100 ohms, kilo ohms. Okay, 100 kilo ohm. This one 20k kali multiplied by range is 5 volts. Okay, so the answer will be 100 kilo 100 kilo. So the R, okay, the R, okay, the R, the RT, this means Rm, okay, R2 parallel with Rm lah. Okay, because we connect this one so this is another this one, so that's why resistor here Rm okay. For the part B, we connect to meter here, alright, that's why R2 and Rm is the parallel. Okay, so I put parallel here okay, so as you know, the Rm equals to 100 kilo ohms and R2 will be 50 kilo parallel. Okay, kilo ohms, 50 kilo ohms. So the answer will be 33.3 kilo ohms. Okay, so so this one you have to know lah how to calculate 1 over RT. Okay, 1 over R2 plus 1 over Rm. Okay, so this one R2 Rm plus R2. Okay, so 1 over RT. So RT equals to R2 Rm divided by Rm plus R2. Okay, there is formula for parallel lah. Okay, using the formula for parallel. So to get this value lah, so the value here will be 63.3 kilo ohms. Okay, and then we can use the voltage divider rules. Okay, to calculate the VR2 equals to, this is resistance. Okay, calculate this one RT. Okay, RT plus R1. Okay, so the RT can get 33.3 kilo ohms. Okay, 33.3 kilo ohm plus 70. Okay, R1 is the 70. Okay, multiplied by 12. Okay, multiplied by 12. Okay, so this volts. Okay, so the answer will be 3.7 volt. Okay, the answer for VR2 is the 3.87 volts. Okay, So it's the same same answer. Okay, so next you can see for the part C, okay, the sensitivity is the 200. Okay, 200. Okay, will be same. Just you can see the same concept lah, using the similar like this one. Okay, similar like this one. So the S equal to part C. Part C you can try yourself. Okay, so part C will be 200 kilo. First you have to calculate the RM. RM equals to, okay, S 200 multiply kilo, okay, kilo ohm per volt, okay, multiply by 5, okay, get 1000 ohms, okay, and then this RM parallel with R2, okay. This is for part C. Part C you can try yourself lah. Alright, so try yourself. Okay, so and then you can get this one RT. Okay, RT that means RM equal to 1000 kilo. This one 1000 kilo 1000 kilo ohms. Okay, parallel with 50 kilo ohms. Okay, so you can get the RT. Okay, and then you can use the voltage divider rule lah, this formula. Okay, so the answer for part C is the, okay, for VR2 part C is the 4.86 lah, 86 volts. Alright, so this is for answer for the question 7 question 7 part C. Alright, if the sensitivity of the 200 kilo ohm per volts. Okay, this one 200. Okay, the same step lah with the part B. Okay, first calculate the RM. Okay, this is formula for RM. Okay, sensitivity kali multiply by range. Okay, and then after get the range, okay, so it connected here. So the meter will be connected here. So this is our RM and full scale distribution of current lah. Okay, full scale distribution of current here. So that's why you can see this one R2 with RM here will be parallel. Okay, so will be like this lah. Okay, if we draw it back, so this one, this is R1, this is R2. Okay, actually this is our RM. This is R1, R2, this is RM. That's why you can see this R2 and RM is the parallel. Okay, is the parallel. That's why you can use the formula of parallel to get the RT here lah. RT here, okay, and then you can calculate the step by step. Also you can calculate the previous one lah. So calculate the current here first. Okay, after you get this one, okay, the parallel this one plus with this R1. Okay, that means current voltage divided by R total lah. So R total R1 plus parallel of RM and R2. Okay, the voltage given is 12. So you can get here. Okay, can get here. So current here. Okay, next you can use this, okay, to calculate the current part here lah. So the current will be point this one and another one here. Okay, right. So this is the step by step, but you can use straightforward lah using this one using the, we call the voltage divider rules. Okay, this is voltage divider rule lah. Straightforward, you can use this one lah, this formula, because this voltage, okay, actually voltage here and voltage here is same because of parallel this one voltage here, you calculate this one and voltage here will be same. That's why you can calculate straightforward using this one voltage divider. As you know, it's calculate this one voltage here and automatically we know this voltage because of the parallel, the voltage will be same lah. Okay, all right, so I think that's all for today. So I just left another one question number 8. Okay, so for the question number 8, I think I give all of you to try this one. Okay, so this assume as your assignment to answer for question number 8. Okay, question number 8, and then submit to me lah. Okay, submit to me. Okay, through email lah. Okay, so for the question number 8, you have to try and submit to me lah. Submit to me next week. Okay, good. For the question tutorials tutorial 2, question number 8 as your assignment, assignment 1 lah. So you can try yourself, okay? Alright, clear Okay, for the tutorial 2, question number 8, you can try as your assignment 1, assignment 1 lah. Okay, this is individual, okay, individual assignment. So you can send to me next week, okay, for the answer for the tutorial 2, question number 8. Alright, so I will stop here. Any questions so far?
Tak ada, sir.
Alright, so, okay, kalau in case you nak, you boleh tengok balik. So after this one, after this class, saya akan upload this video, okay, my class video on the YouTube lah. So you can refresh balik lah on the, okay, you can boleh tengok dekat YouTube saya. Every class saya akan cuba upload dalam okay, dalam YouTube saya. So kalau you lupa, so you boleh refer balik to YouTube. Boleh
Boleh, sir, boleh.
Alright, so I will stop here. Okay, so tomorrow we cover for the tutorial 3, we will cover for tutorial 3. So maybe you can try first, and then tomorrow we will discuss on the tutorial 3. Okay, next week I will be focused for the next topic lah. Okay, alright, so that's all for today. So I think, okay, understand? So the question number 8 you can try and submit to me. This is your like assignment 1 lah, okay? Individual assignment, so you have to submit to me next week through email, my email. Okay, boleh
Boleh.
Okay. Alright, okay. So that's all for today. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, bye bye.
Waalaikumsalam.
Okay, sama.